Hi, welcome to Sujata Math Solutions. Today's topic, mensuration. In mensuration, we are discussing 3D shapes. 3D means three-dimensional shapes, which is having length, breadth, height. For example, see the duster. Yes or no? See, it has three-dimensional length, breadth, and height. Okay, length, breadth, height. So, which is having length, breadth, height, these are three-dimensional shapes. So, this is the shape of cuboid. Okay, cuboid. Cuboid, it has the shape of the cuboid, it has 6 faces. 6 are rectangular faces. See here, this is one face and opposite also, opposite face 2. And here, this is one face, this is one face, totally 4. And top or bottom. Totally it has 6 faces and 12 edges. Edges, how can you count? See, these are the edges. 2 walls meeting point. 2 walls are, see, this is 1, 2, 3, 4. Top 4, bottom also 4. 1, 2, 3, 4. Okay. This 4 and bottom also 4 edges. And here 1, 2, 3, 4. Totally 4, 4 and 4. 12 edges. So cuboid has 6 faces and 12 edges and vertices are 8 vertices. 1, 2, 3, 4 and 5, 6, 7, 8. These are vertices. Okay, 8 vertices. Now here, now we discuss what are the features of the cuboid. See, for example, this is the classroom. In our classroom, it has 4 walls of the room and the top or bottom. These 4 walls of the room are lateral surface area. And the total means we have to add top and bottom also. Right. Now see the cuboid. This is the cuboid shape. Okay, this is cuboid. First one, cuboid. Cuboid, it has 6 rectangular faces and 12 edges and 8 vertices. Now, here, this is a rectangular faces. Rectangular faces means opposite sides are equal. Suppose in this room also, opposite sides are equal. These opposite walls are equal. Yes or no? So, suppose this is one wall, A, B, C, D. This is A, B, C, D, one wall. Opposite wall is E, F, G, H equal to E, F, G, H. These two are opposite walls. Means this is one wall, this is one wall. Right. Next. And also this is another opposite walls. This and this means A, D, H, E. A, D, H, E equal to, here A, D, H, E opposite wall is B, C, G, B, C, G, F. Why I am saying here, opposite walls are equal in the, opposite sides are equal in the rectangle. See, suppose the board also, opposite sides are equal. If you find the one wall of the area, opposite wall also same area. So that these 4 opposite walls. 4 walls. This is opposite wall is this, means ABCD. This opposite wall is this and this opposite wall is that. So total surface, lateral surface area means area of the 4 walls. Okay. So LSA, lateral surface area, we have to say LSA. Okay. LSA. LSA, here we are finding 4 walls of the room. 4 walls means here except top or bottom. Okay. 1, 2, 3, 4. These 4 walls only we are finding. Not top or bottom. Okay. except the top and bottom remaining walls we are finding, right? So this is the length of the length. AB is the length, here it is the breadth, here it is height, and also these are the heights. Next, these are the lengths. This is the breadth. Okay, if you find one wall, means here one rectangular, we are finding the one rectangle area, opposite rectangle also same, right? So that here from the A, B, C, D, what is the area? Length, height. So that here first one is LH, length into breadth. Breadth as here height. This opposite wall, what is the opposite wall? EFGH. EFGH. EFGH also same only. Yes or no? LH. This also length into height. Means plus LH. Plus next opposite walls. Two walls. These two walls are completed. Remaining these two walls. That means here ABCD opposite wall is EFGH. If you find one area, opposite wall also same area, L into H. And next opposite wall here, ADHE. Opposite wall is BCGF. These two are opposite walls. These are lateral surface area. Okay. So first see the here ADHE. ADHE here length as breadth, height. Here breadth and height. So BH plus opposite wall also BH. Okay. So in this 2LH plus here BH, 2BH. And also what we have to take the common 2H in the both terms. 2H take it as the common L plus B. This is the lateral surface area of the cuboid. Okay. Next, total surface area. Total surface area, we have to add top and bottom. We have to add top and bottom. See, what are the tops here? This is the ABFE. ABFE equal to, these are the tops, base areas. Top and bottom. Top and bottom. Okay. So, what is the opposite here? Top. This is the base. And the top CGHD means BCGH. These are the top and bottoms. So total surface area means we have to add lateral surface area plus base, 2 into base areas. Why? Because here 2 base areas are there. 2 base areas. We have to write the top area plus bottom area, or else 2 into base areas. So TSA equal to lateral surface area plus top area plus bottom area. Here LSA means what here? 2LH plus 2BH plus top area plus bottom area. Top here what is the bottom? L length, breadth. So L into B. And same as top is L into B. Okay. So L into B plus L into B. Total surface area means we have to add top and bottom to the lateral surface area. So this LB 2 are there. So we have to add 2LH plus 2BH plus 2LB. In these 3 terms, only 2 as the common. Okay. So 2 into LH plus BH plus LB. Also can write this 2 into LB plus BH plus LH. Just terms are interchanged. This is the total surface area of the cuboid and also volume of the cuboid. Volume of the cuboid. Volume means, yeah, now volume of the cuboid. Okay, volume of the cuboid. Volume means here we have to multiply base area into height. Why? Because how much space occupies the object. That means the height we are finding. Base area into height. Volume means multiply with the base area into base area with height. So here base area, this is the rectangular shape. Base area means L into B. Okay, L into B, LB, and the height is H. So that LBH. Base area. Here we have to write base area into height. Base area here LB and height is H. So that volume of cuboid is LBH. Next one is a cube. Cube. Here, cuboid both are same. Suppose this is the example of a cube. Okay, cube means it has 4 sides equal. Cube means cube as shape of the cube is square shape. Square faces. It has 6 square faces. 1, 2, 3, 4, 5, 6. 6 square faces. Okay, same as 12 edges and 8 vertices. Right. Now here in this square is cube 6 square faces. See here figure also. See the square cube here. Cube, it has a square 4 sides are equal. Means here cube means 6 square faces. So that each side we are taking as A. Means all sides are equal. Length equal, breadth equal, and height also equal. Okay, all together equal only. Length equal, length, breadth, height, all are equal only. So that now lateral surface area of the cube, LSA, lateral surface area of cube, equal to, here we are finding 4 walls of the room. Okay, in this 4 we are finding only 4 walls area. 4 walls means here area of the square A square. Okay, A square, one area, one square is one wall area is A square. Why? Because side into side. Side is A and here side also A. All sides are equal. So that area of this square is A square. How many walls? Lateral surface area means we are finding 4 walls of the room. 4 areas. That means A square plus A square plus A square plus A square. Total it has a 4A square. This is the LSA of cube. Next, total surface area of the cube. Same. We have to add top and bottom. Top bottom areas. That means TSA equal to LSA plus lateral surface area plus 2 into base areas. Base area. 2 into base area. LSA means 4A square plus base area is base means square shape. Top also square shape. Means A square. I said here base area plus top area also write, or else 2 into base area. Anything same only. So that 2 into A square. That is equal to 4A 6A square. This is the total surface area of the cube. Next, volume of the cube. Volume of the cube. Volume of the cube, already I said, multiply base area with the height. Okay, product of the base area with the height. So that base area is a square and height also a. That is a cube. This is the volume of the cube. One is cylinder. 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 Already in our kitchen, every home we have the cylinder. Cylinder means it has one curved face and two circular faces. Right. See here. This is the cylinder. Yes or no? It is the cylinder. Right. This is one curved face and two circular faces. It has one curved face and two circular faces. Okay. And see the figure also here. Right. This is the cylinder. Cylinder here, these two circular faces and one curved face. Now we have to cut the cylinder with the vertical direction. Okay. And unfold this cylinder. It looks like a rectangle. So that it is a rectangle. When you are see, first this is the rectangular sheet. If you unfold this rectangle also, it becomes a cylinder. Yes or no? So that when you are unfold this, this is the rectangle. When you are folding, this is the cylinder. Now, here, this is the height of the cylinder. Yes or no? Height of the cylinder. This is the height of the cylinder. Now, unfold this. Here it is the length, breadth. This is the length of the rectangle, breadth of the rectangle. Yes or no? Here length is, here my question. Here length is, this is the length of the rectangle. When you are folding this rectangle, it is the circumference circle. Okay? Circle. Length is equal to circumference of the circle. So that length equal to circumference of the circle formula 2 pi r. 2 pi r. Okay. Next, and the breadth of the rectangle. This is the breadth of the rectangle becomes height of the cylinder. So, breadth equal to height. Okay. So, that here length of the rectangle is equal to circumference of the circle, and height of the cylinder is breadth of the rectangle. This is the breadth. Height of the cylinder is breadth of the rectangle. Now, we have to find in 3D shapes lateral surface area, total surface area and volume. Okay, this is a curved shape. So, curved surface area. We are finding here curved surface area, lateral surface area, both are same only. Okay, so curved surface area. Of a cylinder. Curved surface area of the cylinder equal to area of the rectangle. Why? Because the cylinder, when you are cut and open the cylinder, it becomes a rectangle. Okay. So, curved surface area of the cylinder is equal to area of the rectangle. Area of the rectangle. So, area of the rectangle. So, what is the area of the rectangle? Length into breadth. So, that L into B. Here L as 2 pi r. Length equal to circumference of the circle. So, that 2 pi r. Next, what is the breadth? Breadth is height of the cylinder, means h. So that here curved surface area of the cylinder is 2 pi r. h. 2 pi r h. Next one, this is the curved surface area. Next, total surface area, TSA. TSA means here CSA, here curved surface area. Why? Because this is the curved face. Okay. CSA plus 2 into here base, 2 bases are there. So that 2 into base area. 2 into base area. Here base is circular shape. Area of the circle is pi r square. Okay. So that here CSA is 2 pi r h plus base area is here. Area of the circle 2 pi r square. Okay. Pi r square, 2 pi r square. Or else 2 into base area means base area is pi r square. So that 2 pi r square. Compare these two terms. In this 2 pi r we have to take the common. Okay. 2 pi r. If you take the 2 pi r common, h is left in first term plus r is left in second term. 2r, r square means 2r. Okay. This is the TSA of a cylinder. Total surface area of the cylinder. Next one, volume of the cylinder. Volume of the cylinder. Volume. What I said, volume. Volume means base area into height. Okay. Here what is the base area? Base is circular shape. Bases in cuboid, rectangular shape, cube, square shape. In cylinder, circular shape. Okay. Here base area is circular. Base face is circular face. So that area of the circle is pi r square. Volume means base area into height. Multiply base area with height. So that is equal to, here base area circle. Area of the circle pi r square. Pi r square, height is h. This is the volume of the cylinder. Okay. Next is cone. So cone we are seeing in birthday caps. Okay, birthday caps, ice cream cones we are seeing. So this is the cone. Okay, this is the cone. It has one circular face, one curved face and one circular face. Two faces it has. Okay, and one vertex. Now, and also here this is the slant height of the cone. Okay, so now draw the cone here. Right. Here it is a cone. And height of the cone. Height of the cone, we have to draw the line segment vertex from the center of the circle. Vertex from center of the circle, we are making the height. Okay. So this is the height. A, O, B. And here center of the circle to boundary, it is the radius. Okay. And here AB is the slant height. Slant height of the cone. Slant height we are using letter L. So this is the cone. Okay. Right. First we have to find the slant height of the cone. Slant height of the cone. Slant height means studied there here. It forms when your vertical line, vertical you have to draw the line segment vertex from the center of the circle. It forms a right angle. Okay, right angle opposite side is hypotenuse. Okay, hypotenuse means by Pythagoras theorem, here hypotenuse is slant height of the cone. Okay, so that here by the Pythagoras theorem, hypotenuse square equal to sum of the squares of remaining two sides, then we will get the L, slant height. Okay, use the Pythagoras theorem. By the Pythagoras theorem, hypotenuse square, AB square equal to OA square plus OB square. These are the remaining two sides of the right angle. Okay. Here AB is L, means L square equal to H square plus OI is H, OB is R radius, R square. So L equal to, here square becomes a square root, H square plus R square. This is the slant height of the cone. Okay. Now, curved surface area of the cone. Curved surface area. Suppose here cone is it is the sector of the circle. Cone is see here, sector of the circle. This is the circle. Okay. Cone means cone is here. It is the sector of the circle. Okay. Suppose see here cone. This is the cone. Okay. This cone is sector of the circle. Okay. Sector of the circle. Here height of the cone is radius. Means slant height. This is the slant height L. It has a two radius. Okay. These are the slant height of the cone. Means here cone is a sector of the circle. And here we have to form many triangles. We have to use small triangles. Here A, O, B. Okay. Here OA, OB are radius of the circle. At the same time, these are slant height of the cone. Radius equal to slant height of the cone. Right. These are the small triangles. Okay. Here the triangle, it has a base height. Okay. Here height has a slant height L. Base is, these are the base, many base. That means we have to use B1, B2, B3 and so on, like that we are using. Yes or no? And now, if you hold this cone, here these are the small triangle bases. This is the base, here height as slant height. So here height equal to slant height L. Here base, these are the all rectangles, we are bases B1, B2, B3. But height is same L. Okay, slant height. And also when it is, these are the A, B. These edges again, if you join this, it is the circular face. Yes or no? Circle. Circle means this is the total, it is a breadth. All breadths of the triangles are equal to circumference of the circle. That means if you take here B equal to base equal to B1 plus B2 plus B3 and so on. Why? Because these are all equal to, what is that, circumference of the circle. So B equal to 2 pi r. Circumference of the circle is 2 pi r. Simply you have to understand here. If you hold this is the cone. If you hold this cone, again these edges, when you are joining these edges, it is circular. So here all base of rectangles are equal to circumference of the circle. And the height is equal to slant height of the cone. Okay. Now we have to write a curved CSA, curved surface area of the cone equal to, what is that? Actually area of the triangle is half into base into height. Half into base into height. This is the area of the triangle formula. Okay. So here we are using all triangles only. We divided into many triangles. So that half into base. Base, what is the base? Circumference of these all bases are equal to circumference of the circle. 2 pi r into height. H means slant height L. 2 to cancel. Therefore, that is equal to pi r L. This is the CSA of a cone. Curved surface area of the cone is pi r L. Next one, total surface area of the cone. Total surface area means what? TSA of cone. TSA of cone equal to what is that? LSA or CSA plus base area. Base area. Base area. Here CSA means what? Pi RA. Plus base area. Base is circular face. Base is a circular face. So area of the circle is pi r square. In this pi r both are having common. So that if you take the common as pi r, L plus r. Here in first term, if you take the common pi r, L left and here 2 r's are there. So that L plus r. This is the TSA of the cone, curved surface area of the total surface area of the cone. Okay. Next one, volume of the cone. Next one is volume of the cone. Here volume of the cone is equal to here 1/3 of the cylinder. 1/3 of the cylinder means suppose here this is the cylinder. Okay. This is the cone. Okay. So if you take the quantity of the object in the cone, okay, or else take the liquid in the cone and pour it in the cylinder. If you use 3 times, then it fills the cylinder. 3 times of the cone, if you use 3 times of the cone of liquid, fills the one cylinder. So that volume of the cone equal to 1/3 of the volume of the cylinder. One-third of the volume of the cylinder. Actually, volume of the cylinder is equal to volume of the cylinder what? Base area into height, no? So that volume of the cylinder pi r square h. Okay. So that 1/3 into pi r square h. That is equal to 1/3 pi r square h. This is the volume of the cone. Volume of the cone is 1/3 of the volume of the cylinder. Next one is a sphere. Sphere means this is example for balls. Globes, balls, tennis balls, cricket balls, these are all example for sphere. Okay, this is the sphere. Okay, right now. One sphere, this is the sphere. Okay, one sphere equal to this is the sphere. Same radius. One sphere radius is equal to sphere of the. This is the sphere. Okay. Surface area of this sphere radius is equal to 4 areas of the circles with the same radius. Okay. Same radius, we have to draw the 4 circles. Okay, and you have to cut the strings with this tennis balls or any ball and fill these circles. Then it is sufficient for 4 circles. So that surface area of the sphere equal to 4 into area of the circles with the same radius. Okay, so that surface area. Surface area of the sphere equal to 4 into area of the circle. Okay, so that 4 into area of the circle is a pi r square. So 4 pi r square. Right? Now, here if you cut the sphere in two equal parts, okay, equal parts, it comes to hemispheres. Hemisphere. This is the circle, okay. Sphere, not circle. It is the sphere. If you cut the sphere in two equal parts, so two hemisphere. This is one hemisphere and this is another hemisphere. Two hemispheres. One sphere equal to two hemispheres. Okay. Surface area of the one sphere is 4 pi r square. Here hemisphere means 2 divided into two parts means 2 pi r square. 2 pi r square. So that hemisphere surface area of CSA, okay, surface area of the hemisphere equal to 2 pi r square. This is the hemisphere. And also, okay, see here, this is the hemisphere. This is the curved surface area of the hemisphere is 2 pi r square. And this is the curved surface area. TSA, total surface area of the hemisphere. Total surface area. They do not have total surface area. Why? Because only one curved face. So that it has only surface area only. Right? In the sphere. But in hemisphere, it has total surface area. Why? Because it has the one base area. Base part. Okay. So that total surface area means curved surface area plus base area. Base area means it is a circular face. Yes or no? Circular face. So that area of the circle is pi r square. Here it is pi r square. So that here curved surface area of the CSA. CSA plus base area. Here CSA is 2 pi r square plus base area is pi r square. Totally that is equal to 3 pi r square. This is the total surface area of the hemisphere. And next one also here, this is the sphere. Yes or no? Volume of the sphere. Now we have to discuss volume of the sphere. Volume of the sphere means here we have to form the, this is the sphere. We have to draw the, here in this pyramid. Okay. This is the pyramid. We have to draw the many pyramids. Here, height of the pyramid is the radius of the sphere. Okay. Height of the pyramid. Height equal to radius of the sphere. Okay. And we have to form many spheres here. Many pyramids. Many pyramids we have to form from the sphere. Okay. So that here, volume of the hemisphere, volume of the pyramids, we have to find many pyramids here. Okay. So that volume of the sum of the volume, many pyramids means we have to use n number of means the sum of. Okay. Sum of the pyramids is equal to surface area, surface area of the volume of the sphere, not surface area. Here, volume of the pyramid equal to volume of the sphere. Volume of the pyramid equal to volume of the pyramids, sum of the volumes of the, sum of the main means many pyramids we are forming from the sphere. So that sum of the volumes of the pyramids is equal to volume of the sphere. And also here, this is the base. Yes or no? base pyramids. Base pyramids. Here these some of the all base pyramids, base areas. Some of the base areas is very close to surface area of the sphere. That means here surface, here height is r, radius. Yes or no? Here base areas is equal to circumference of surface area of the sphere. That means base equal to 4 5 r square. And pyramid. Here area of the pyramid. What is the area of the pyramid? Volume of the pyramid. What is the volume of the pyramid? Volume of the pyramid is equal to 1 by 3 into 1 by 3 base area into height. Okay, base area into height. Here, so that volume of sphere equal to volume of the sphere equal to sum of the volumes of the pyramids. Okay, here and bases are equal to surface area of the sphere. So that 1 by 3 into base. What is the base? 4 pi r square. 4 pi r square into height. Base area into height. No? Into height as radius. Here height of the sphere, here height of the pyramid is radius of the sphere. So that is equal to 1 by 3. 1 into 4, 4 by 3 pi r into r. So that this is the volume of the sphere formula. 4 by 3 pi r cube. Now volume of the cube we know. Now volume of the sphere, volume of a hemisphere, half of the volume of the sphere. Okay. So volume of hemisphere. Volume of hemisphere equal to half of volume of the sphere. Volume of the sphere, that is equal to half into volume of the sphere is 4 by 3 pi r cube. That is equal to here 2 times. That is equal to 2 by 3 pi r cube. This is the volume of the hemisphere. So thank you friends. This is very interesting subject. Not it is hard. So that everyone you have to concentrate and like this videos, share your friends and don't forget to subscribe. Thank you.